Hi there, I hope you guys are doing great. I am Animesh, and in this video I'm going to show you how you can use pandas interpolate function to impute the missing values for a numerical data. So let's get started. I have imported certain libraries like pandas, numpy, matplotlib, seaborn, datetime, and I am importing a time series data frame which is nothing but a date-wise electricity production values. So once I have this data, I will check whether there is any missing values or not. So I will simply type tf.info and I'll execute it, and I can see that there are no null values. All the entries are filled. So in order to create some null values, pass this command so that I get some null values at these rows. So I'll just check now. So yes, I can see that there are few NaN values in our dataset. Now in order to impute these NaN values, we are going to use the interpolate function. So what we are going to do is we are going to simply pass df.interpolate and method as linear. So we can pass this for the whole dataset. We can pass this for even a single column or multiple columns, but for now let's just pass it for the whole data frame, and I'll execute it, and I see all the values that were NaN are imputed. Here we have passed the parameter method is linear. So this argument gives the function that I want to impute the values in the linear way. I can change this to polynomial as well, but then if I mention as polynomial, this will also require one more argument, that is order, that is of which order you want to impute. So I'll just change it to polynomial, and then I will just pass of order say 2, and then again I'll just rerun it. So it will impute with a polynomial with order 2 values. So if I want to understand what is happening behind the scene, if I pass the value as linear in method, so if I give it a linear parameter and then I execute it, so how this 64.07 is coming? So it is nothing but a linear value, which is nothing but the average of these two values, one the value which is preceding this value, and the one which is succeeding this value. So by calculating 70.672, that is this value, and 57.4714, I just sum it up and then I just divide it by 2. The value that I get is 64.07, so it is exactly the same. So this is how behind the scene it is doing the calculation. Now moving further, if we want to save this particular data after doing this imputation, what I will do is, one, I can just simply pass in place true, and simply I can just run this command and it will save as a new preprocessed data frame. But otherwise I can instantiate it also using df is, and I can remove this in place as true, also fine. So now you know the basics of imputing the missing values using interpolate. Now let's enrich our skills on imputing using interpolate. So there are other important arguments that we can use in different scenarios. Now what those different scenarios can be, say for example, if the NA value is in the extreme end, say in the first row it is there, or it is in the last row, let us create one. So I have created NA values in the first row and I'll just execute it. So I just rerun it just to see. Yes, we have it in the first row. And now I want to impute the same interpolation that we did earlier. Here I will do a little bit of change. I will add the column name as well, since we didn't try that. So let's do that as well, and I execute it. So this works fine with the column name as well. But here you will see that all the values were imputed except the first value. So this is one thing that we should remember while using the interpolate function. Here we haven't mentioned any method that gives the direction of the imputation, like the limit direction. So there is a feature which gives limit direction. So by default the argument is none, but if we give the argument with limit direction as both, so it could be forward, it could be backward, but if I mention it both, then it will start the imputation in both the directions, because it starts with a certain direction. So first value, if it is nan, then it doesn't have any preceding value with which it can interpolate, so it needs at least two values to interpolate. So by both, it will have a previous value, and if it doesn't have the subsequent value, then it will give the same value which was there, that is 70.6720. So now let's just execute and see. So here I see it got imputed, but it got imputed with the value that was present in any of its adjacent row. Got it? So now let's go in one more level in the depth of understanding. So let's just try it out with the first row as NaN as well as the last row as NaN. And now we will try using the interpolate method. So we will use some more arguments. Instead of both, we will try the forward one, we will also try the backward one, and we will also see one more argument that is very interesting. So let's start. So now since we have this already done, so I'll just take this code and I'll just keep it here, and instead of limit direction I will just pass forward. So it will be forward, and let me just also see the data frame so that it will give us a better picture. And see, we have a lot of NaN values in the first and the last row. And now just execute this. So we see using the forward argument with limit directions, it imputes the last row, but it doesn't impute any of the first three rows. So our first three rows remained as it is. Why? Because the direction of the imputation was forward. So when it doesn't have any preceding value, how it will get imputed? And if I give a backward direction, now this will bring more clarity, and I execute it. So now you can see it is other way around. The last value still remains NaN, but the first three values are imputed. But those are imputed with only the value that was present in the fourth cell, fourth row. Okay. Now let's play around with one more argument, which is nothing but limit argument. So we can pass any value which is an integer. This is an optional argument. It says that it is the maximum number of consecutive NaNs to be filled. It must be greater than 0. So I give it a number 1, and now I execute it. Now you may see that it has imputed only one value. The one that was present in the fourth, it took exactly the same value. Had I given it 2, then it would have imputed two values. But by default, if I do not give anything, then it doesn't have any limit. It will give all the values which are NaN, all the consecutive, whether it is 5, 10 or 1. So let me just do that, and I'll remove this limit, and instead of backward I keep both, and in this way I get all the values imputed. So that's it in this video. So we talked about what is interpolate function of pandas with different arguments, linear, polynomial, limit direction, as well as limit. I hope you guys were able to understand the concepts, and now you are confident and equipped with this particular skill using interpolate in any data frame. So I'll see you in the next video. Please don't forget to subscribe to my channel. Till then, bye bye.